Welcome to this new video in which I will program a search-based chess AI. First, a few notes on what you should kind of know about Python. So I will expect everybody to know just how to program in general and how to use Python, but will either way guide you through the concepts that pop up. Also, we will use a couple of libraries such as NumPy, which would be handy to know, but again, you don't need much prior knowledge. I will explain everything as I go. And for this very first episode, I will implement some of the basics of the chessboard. So I've already created this new repository, and we will just jump in by creating a new file which we will call chessboard, and we will open up with a new class, again chessboard, and then we will give this class a constructor, and we will call this constructor, or constructors in Python are always called init, with this double underscore notation. And then in here we will want to use a array to represent our chessboard. So most of you, I think, will be familiar with this look of the chessboard. And in here we usually have a 2D board. So we have first a X and then a Y direction. And for storing the chessboard, to do that optimally, we will want to store this as a one-dimensional array. So we will have indices ranging from 0 to 63. And that means that, for example, A1 here at the bottom left will be the number 0, and then in the top right corner will be H8 will be index 63, and we will go in rows to the right and to the top. Yes, so for this we will use, first of all, we will create this variable, and we will call it just board for right now. And now for optimal storage space and also handling, we will use a library called NumPy. And first of all, I will maybe just create our array. So we will say numpy.zeros. We want to have a length of 64, and we will say dtype is equal to numpy.int8. And now we will import this. So just at the top here, we will say import numpy. Usually you import it as np. So we will abbreviate this to np in both spots. And that's fine. But we will use this library in multiple different spots, and so therefore we will go ahead and make the imports a little more handy. So we will create a new directory, which is called lib. And then in this directory, we will create a new file, which is called init. And now we can put all of our imports into here. So we will also say from chessboard import chessboard for later. And now we can just say from lib import everything. And that will take care. So you can see there's no error on the import. And now we should have an empty board array. And now it would be handy if we could sort of have a look at our board. So, I also forgot, since this is something we want to have access to later, we will say self. The board is instantiated as a variable of the object. And now we will create a runnable script. So we will create a new Python file call it main. And in there we will now first of all again say from lib import everything, and then we will say this is how you create a runnable script in Python. So you say if name equals to __ main, and now you saw this little arrow appear on the left hand side, and this just means that once we click it, all of the code below will be run. So we can, for example, say my chessboard here, and then we can instantiate a new chessboard like so, and then we can maybe say print my chessboard dot board. And if we do this, then you will see a long line of zeros, which of course is what we programmed, but will not be very nice to look at. And before we have a GUI, I created a small class that will make it a little bit easier to look at our board. So we'll take a quick second to need to worry about this, since it's only here until we have a graphical user interface. But if you want to, you can of course take a look. And now we will again import this. So we say from print utils import print board, and then we can go into our main method, and below here we just say print board of our my chessboard object. And if we now run this, then you can see in here that it first again printed our board in this linear representation, and now with the print utils class. So you can see I've denoted the ranks and files, and then in each of these you have a value. For right now it's 0. Later on we will fill these up with specific values according to pieces. Okay, so I've just mentioned ranks and files, and in chess you call the columns files and the rows ranks. So we have visualized that here, but you can also see it in our print. So A would be a file and 6 would be a rank. And with this, we can then specify one cell. So for example, A1 is here at the bottom, or H8 is here at the top. But we have a shorthand for any cell, and we call this the algebraic notation. And for later, it will be handy to have sort of a way of parsing from our indices, which range from 0 to 63, to our algebraic notation, because that's just more natural. And that's what I'm doing here. Now in the beginning I was figuring out the name a little bit. I want to make it a little shorter. And then we're taking in the algebraic notation of a cell. So for example A1. And we want to extract first the file from it. So that would be a character, for example A, and we want to get that into an integer. So we take the ASCII value, that's what the RD function is doing, and then we subtract the ASCII value of A to shift it into the range 0 to 7. Then for the rank, we have the number in there, but as a string. So we use the int function to extract it as an actual number. And that's the second character. And then we again shift it into the range 0 to 7 by doing -1. And now we can put that together with this neat little formula and return it as the index. And now we'll quickly test that. And so here, for example, we want to pass A1, that should be 0, and H7 should be 62. So this is working pretty well. I don't think you really need to understand the formulas here or even little bits of code because it's not really particular to chess. Then we're going to do the opposite. So we take in an index and we want to again extract the rank and file from it. For this, we're going to divide the index by 8, so by the amount of files, and we're going to do a modulus of it. And then we, for the file, want to convert that into an actual character, which this chr function does. We use the floor function to round down, and then the rank is similar, just with the modulus. Again, not really important to understand how it works, but just know that the file will be a character between A and H, and the rank will be a number between 1 and 8. We concatenate the two here and then return it as our algebraic notation. And now we can also test this. Okay, I had to change it to import the floor function directly in our chessboard class, which is not an issue. Now we can use it here, and you can see the output is, as we thought, A1. We can also try this with, for example, 63, which will be H8. Yeah, that works as we would wish it to. And now we will be able to use this to make moving on the board a little bit more intuitive. Okay, and I think that's enough for our first video. Thank you very much for watching, and please leave me your feedback in the comments. And in the next episode we will implement some basic movements.